Hi, it's Dr. Baumstark again, and this is a video tutorial and explanation of the Dynamic Host Configuration Protocol, or DHCP for short. So here's a scenario. You are a sysadmin at say a medium-sized company that has 100 computers that you have to administer. Now, all these computers have to want to be connected to the network. Because in this day and age, you pretty much don't have any kind of let's make that look a little better. In this day and age, you don't want a computer that's not. I mean, that's what makes our businesses run and our lives much more fun and productive, right? So every one of these computers needs to be connected to the internet. So among other things, each one of them needs an IP address. They need to know about a DNS server so that they can resolve host names, and they need to know the IP address of a gateway. We haven't talked much about gateways yet, but if you recall, a gateway is a route that computer knows to go through to get to the internet. So all of its packets sent out to the larger internet will go through that gateway. So these are a minimum 3 pieces of information that we really need before we can have a functional computer that can communicate on the network. It needs an IP address because it needs a unique address for it to send and receive data. It needs a DNS server so it can do host name lookups, and again, it needs a gateway so it knows how to get out to the internet itself. Now, you're a systems administrator, and you have to configure all of these machines. So machine 1, 2, 3, all the way up to machine 100. You have to configure all of these machines with these 3 pieces of information. Now, let's say, for example, they were Windows machines. We could bring a control panel on each one, go to networks, and get our connector settings, and you go through all this rigmarole, go up to Internet Protocol version 4, look at the properties, and you could actually input IP address, gateway, DNS server, subnet mask. You can input all this stuff directly. And you could do that manually for all 100 machines that you administer. And that would be a major pain in the neck, especially if something changed. You'd have to go out to that machine, change its IP address and change its information, all that good stuff. And it's just the scale of the problem will get to be too much for one person or even a team of people. What's more, you could be in a large company that has thousands of computers. Thousands of computers that are distributed among multiple buildings in multiple cities and maybe even in multiple continents. At this point, managing the IP settings for each of these machines individually is just the problem is insurmountable if you have to do it manually. So enter the concept of DHCP. DHCP says that all these machines can request their configuration information from a DHCP server. In fact, the process looks very like the minute you plug your computer into the network and turn it on, it gets IP address, DNS server, gateway information, all from the DHCP server. It's a very nice tool. It's a very important tool for managing even small networks. It's hugely important for large networks. This is one of those things that will just save you a lot of time. Most of the work in dealing with DHCP you can do from the comfort of your big fat chair in your office, simply configuring the DHCP server. Very little actual work has to be done on the DHCP clients themselves. In fact, all you have to do is set them to obtain an IP address automatically. And we'll go back to what we saw a minute ago. When you configure your Windows box and you have it to obtain an IP address automatically, that means it is acting as a DHCP client. When it's plugged into the network, it requests from the network, and ultimately from a DHCP server, an IP address, DNS server IP, as well as a gateway. Notice you can manually set the DNS server addresses, but for most home systems and even most business systems, you're just going to have your DHCP server give out that information. So that's actually what's happening when you go into Windows and do this obtain an IP address automatically. That says it's acting as a DHCP client, and it's using that to get its connection information. Now, there's some problems with this idea. The first being, how do I get an IP address when I don't have one to begin with? So, problem one, no initial IP address. Once again, this is the idea of when your computer first connects to the internet or to the network, it doesn't have an IP address. This means that it can't receive IP packets because there is no IP address to be the destination. So that's one problem we have to get past. The other problem is, what's the IP address of the DHCP server itself? We don't know that. Typically, if you're dealing with internet communication, you have a source and a destination IP address for sending and receiving packets. In this case, we don't have either one. And yet we still have to communicate with this DHCP server when we first connect. So, before I get into the more technical details, let me set up an illustration. Imagine you walk into a darkened room. There are lots of people in this room. And you need an IP address to be able to talk with all these people. Now, one of these people happens to be a DHCP server, but you don't know which one because you can't see. You can't see, and you can't really talk to anybody either. All you can do is you can walk into this room and shout, "I need an IP address." And if you're lucky, that DHCP server is going to respond and say, "Here you go. Here's the information you need." Once you configure yourself with that information, then you can talk to everybody in the room. Granted, it's kind of a weird example, but that's the idea. When you first connect to the network, you're blind. You can't send IP packets. You can't receive IP packets, at least not in the normal way we think about that. And literally what you're doing is you're yelling into the network and saying, "Hey, is there a DHCP server out there, and can you give me an IP address and this other information?" So let's look at a particular mechanism that makes this possible. And consider this a sidebar where we talk about broadcast IP addresses. So you may have noticed when we were talking about subnetting for, say, this subnet. Everything that begins with 192.168.100, the range of values actually of allowed values actually goes from 192.168.100.1 up through 192.168.100.254. Now, this field, like the others in the IP address, is 8 bits long, which means it can take 256 possible values, which really means it takes the values 0 through 255. Well, notice 0 is outside of this range, as is 255. We leave out 0 because 192.168.100.0 is the subnet prefix. So we use that to represent the subnet, and so it's reserved for that case. By the way, all this assumes a mask of 255.255.255.0. The 255 address itself is the analog to the subnet. Literally, we take all of those trailing 0 bits in our subnet designation, and we replace them by 1s, which in this particular instance gives us 255. This becomes the broadcast address for that subnet. And what that means is that any machine connected to the subnet will actually receive a packet that is destined for this address. So any broadcast address says that anybody on that subnet receives that packet and processes it as if it was intended for them. The idea is one source can send out messages to everybody by sending out a single packet. It makes things more efficient. That's all I'm going to talk about for broadcast addresses on a subnet. We're going to look at for the rest of this time, we're going to deal with the more general broadcast address, 255.255.255. 255.255.255.255. If you're looking at this in binary, this is 32 ones. And this is a special reserved address that is also itself a broadcast address. So any machine that receives a packet sent to this broadcast address will assume that it is the destination. And again, it's a way that one machine can send a message to a lot of machines by only sending out a single packet. And all those machines, if they're listening in on the same Ethernet or wireless or whatever, they're going to receive that packet as if it was intended for them. Now, this becomes the mechanism by which DHCP answers the questions of the previous slide, this slide. No initial IP address, no problem. We're going to the DHCP server is going to send a response back to us via the broadcast mechanism. Do we not, in the second problem, we don't have the address of the DHCP server itself. Again, not an issue with a broadcast because we can yell out into the room using a broadcast address. And only the DHCP server, since that's what the role it's performing, is going to respond in this case. So let's look at the basic protocol of a DHCP client. A DHCP server. And just for kicks, let's put an other box here. This is any other machine that's on the network listening. So our DHCP client at the start of this process does not have an IP address. Does not know the IP address of the DHCP server. So when it's first hooked up plugged into the network, it's going to broadcast to 255.255.255.255, which means everyone listening in on the network is going to receive that packet and attempt to process it. So that's why I drew the line like this. All the machines on the network will receive it. Now, the DHCP server, since the packet was crafted as a DHCP request, we're going to call this a let me double check to make sure I'm getting the right sequence of events. I'm sorry, request is not the first. This is called a DHCP discover method, discover packet. This is the part where you yell out into the room and say, "Hey, is there a DHCP server out here?" and this is done using the broadcast mechanism. Assuming there's a server out there, it's going to respond with a DHCP offer packet. And note that the response still uses the broadcast mechanism. So everyone else is going to see it. The thing is, since nobody else requested is looking for DHCP information right now, they're just going to ignore the packet. Same for the DHCP discover method. It's only going to be looked at by a machine that is actually a DHCP server. Others are going to receive the packet, see that it's not meant for them, and they're just going to ignore it and toss it out. Now, the DHCP offer is the server saying, "Hey, I exist. I have some information you could use if you want it." And let's assume that, yes, the client does want it. So it's going to send back a DHCP request. "Yes, I'm interested in your information. Will you assign that IP address to me?" If the DHCP server still wants to do that, it's going to finish with a DHCP acknowledge. I spelled that right. And just let me double check myself. Yeah, they call it a DHCP ACK in the literature. So we'll get rid of that. That makes it a whole lot easier. So a four-step process. The DHCP client says, "Hey, I'm here. I need IP information. Is there a server in the network?" So that's the DHCP discover, and it is broadcast. So it's sent as an IP packet, but it's sent out to the broadcast address because we don't know this guy's actual IP. A server responds with a DHCP offer. Again, that is broadcast because the client still doesn't have an IP address to be a destination. The client, at this point, we probably do know the DHCP server's IP, so we can send the DHCP request directly back to it. You could also send it as a broadcast. It doesn't matter much, I don't think. And then the acknowledgement is probably broadcast too because the client doesn't have an IP. Whereas the request says, "Yes, I want the information you've got." The acknowledge says, "Okay, it's yours," and we're done. And at this point, the DHCP client has, hopefully at the least, an IP address. It knows the IP of a DNS server that it can use to resolve host names, and it knows the IP address of a gateway, which it can use to send its packets through on the way to the internet. You can actually send a lot of other information to a client via a DHCP server via this whole process. These are just three very typical things that we're going to do with that. So all right, well that is a DHCP in a nutshell. Again, if you have questions about this, please feel free to contact me via email, pronto, whatever. All right, looking forward to hearing from you.